you measure the angle of that one, 25 degree. Whatever the inclination will be given from the x-axis, you take it. Or if you have taken f1 axis, so measure in the problem it will be given between f1 and f2 how much inclination is there. You are also showing if angle will be given, then what will there here, this inclination, this inclinations. If you will subtract, then you will get the angle between the f1 and f2. So you draw the angle from here on. This way you will proceed, and final point, initial and final point you will join. Then you will get the resultant of this one's number of forces. Other method is there, you draw the perpendicular here. So take this is as your origin and this is the coplanar force. So we draw the xy line. Draw the vertical component from here parallel to the y-axis. So this component will give you the y component, means vertical component of the force, and this will give you the horizontal component of the force. Same way you draw here, this way, here this way. So you are seeing that if you will draw three forces in the positive x direction and one force in the negative x directions. So you sum it all. So find the component of all the forces in the x and y direction, then sum it, f1x, f2x, f3x, f4x, or f1x, f2x, f3x, f4x. This will give you the summation of fx force. And here you are seeing for the f4 force horizontal component you will get in the negative directions. So finally you will get this one. In the same procedures you have to repeat for the y component of that one, and then you will get the summation fx and summation fy. So resultant will become a square root of summation fx square plus summation fy square, and inclination of the resultant will become alpha to tan inverse summation fy by fx. Again, some from where sound is coming. Who is speaking? Again, I have muted to all students. Again, someone is. Amit Jha? Amya Jha? Amya Jha?
Yes, sir. Yes, sir.
Why you are not muting your mic?
Sir, my mic is muted.
No, here it is showing unmuted.
Yes, sir. I was talking right now, therefore I unmuted my mic, but it was muted before.
No, I am searching who is whose mics is unmuted and telling so many times. I have told him mute your mic. Okay, so this way we will get the resultant of that one. Okay, all the forces. So one method is this, another method is this. If you see, the one method also is there, that when three forces is there, for two forces you can draw the parallelogram law of forces that you have seen here. Here two forces is there, inclination is there, so by one resultant of this one of the two forces you can get the there. Suppose that somewhere this AD is F2 and DC is F1, because AB is parallel to CD, so whatever the magnitude of this one will come to the CD, and directions is also both are the parallel. So this one become F1. So see here, three forces is there, F1, CD, this will become F2, and this is the F3. So can you tell me, any students can tell me, this is the coplanar concurrent force F1 and R are the coplanar or concurrent force is there or not?
Yes.
Yes,
Yes,
sir.
sir.
It is coplanar and
Yes.
Yes, sir.
concurrent.
Yes, sir. They are both.
So you can tell that F1, F2 are all are three coplanar
Concurrent.
concurrent force.
Yes, sir.
Okay.
And
So originating point here A. So
A.
you can see F F2 is in the horizontal direction x-axis. F1 is inclined with some angle, and R is also inclined some different angle. Imagine in such a situations that from the ceiling, in the ceiling 2 different points. By the string, iron string, you have put a rope and you have kept in between the pulley, and that pulley is also supported by the other point on the ceiling. So at 2 points on the ceiling, by the 2 wires, that rope is and that pulley is supported. Okay, and from the pulley a weight is hanging. So you can visualize that pulley, on the pulley a point is there where tension in the string in one direction, tension in the string in the other, and weight. So tension T1 will be here, T2 will be there, and weight is there. So these three forces are meeting at a point, and that is inclined that it will be written that the point 1, that first string which is hanging from the ceiling, that is inclined 45 degree with the vertical direction. Okay, from the vertical direction 45 degree is inclined. So you are knowing that inclination is measured in the anti-clockwise directions. So at the point you draw a vertical line and you see that how much inclination is there. By that one way you can measure it. So in the same way, either from the horizontal or from the vertical, it will be given in the problem. So the string inclination you can calculate from here. So for rope 1 and rope 2, you can get the inclination and put in the rope that tension T1, and in the rope 2 tension T2 is there, and weight is there. So suppose that in the problem it is written that this weight is acting and this rope is inclined with some angle, this one with horizontal or vertical it will be given, and this one is also inclined with some angle, horizontal or vertical, and in tension someone is given and you have to find in the tension in other string. So you, because this system tells you this is the coplanar and concurrent forces there. So all the forces are meeting at a point. These things you have to keep in your mind. So here you have studied the Lami's theorem that when the if a body is in equilibrium, means whatever I am discussing, everything is in the equilibrium position. No external force is acting. Okay. So all systems are in the equilibrium conditions. So if they are in the equilibrium, it may be analyzed by the under the actions of the three forces by the Lami's theorem. So Lami's theorem, if in the objectivity there, Lami's theorem acts when the system is in unbalanced, balanced equilibrium. Then you have to tick it at, select it that system is in equilibrium. So Lami's theorem states that if a body is in equilibrium under the actions of only three forces. In this parallelogram, I have discussed about the two forces, resultant is the three forces. So outcome of this one, you will see the three forces. You can also derive the Lami's theorem here. So Lami's theorem states that if a body is in equilibrium under the actions of three forces, each force is proportional to the sine of the angle between the other two forces. Each force is proportional to the sine of the angle between the two forces. So if I will take F1, so F1 divided by sine of theta between the remaining two forces. So here three forces is F1, F2, R. So F1 by sine of angle between F2 and R. So it will become DAC, whatever the angle will be there. So F1 sine of angle this is equal to F2 sine of angle between F1 and R, CAB. And this is equal to R. This is equal to R sine of theta. If you have taken R, so you saw here that R is here. Okay, it is extending. You think that this R is coming from here. So this is the R. This is the direction. So remaining angle will be become F1 and F2. 1 minute. Hello. So you can calculate the R by sine of theta. So suppose that if F1 you are knowing and F2 you are knowing, R you have to calculate, or R you are knowing and inclination you are knowing. So this one will give you the F1 or F2 and F3 and sine of angle between this. So you have seen here, when two forces is there, then you have find out the resultant. If three forces is there, and for finding out the resultant, first you have converted into this one, and you have put calculated the component, square it, and then you have calculated. So it takes the time. This Lamy's theorem, just you have to put this force F1 and sine of the angle between the remaining two forces. Three forces is there, F1, F2, R. If you are taking F1, so remaining two forces will become F2 and R. If you are taking R, then remaining two forces is F2 and F1. So if numerator, whatever the force you are putting, F1, R and F2, so whatever you will put, remaining of sine of angle between the two forces. This will be the Lamy's theorem. So by this way you can calculate whatever the inclination is there. So whatever I have discussed in the rope, that a pulley is suspended from the ceiling of the buildings, and through the two wires hanging, and whatever the tension in the rope, and you have put some weight. You have seen that in the elevators, you have seen how the pulley is moving and the ropes is there. That is suspended in the one is suspended from somewhere. You have seen, and that is elevator is suspended by the pulling. So you are seeing that it is moving, going somewhere. Sometimes if some persons will be there, then the tension in the rope will become the different, and you are knowing the strength of the rope, and by that way you are calculating that how much passengers is allowed to stand on the elevator, and this way you are calculating. So you have understood that how you will calculate the forces. If two forces is there, how we will calculate the resultant. If three forces is there, then how we can find easily of this one. And then next is the this also I have discussed about that this one. This analytical method also yesterday I have discussed that how you have to calculate the forces of this one. So next we have system of forces is there. Then the moment of a force that I have discussed somewhere yesterday class, that remaining things of that one. So Up to here we have discussed about the coplanar concurrent force. So all the forces lie in the single plane, and line of action of all the forces is passing through a single point. When all the forces is lying in the same plane, here are the two variables, plane and point. All forces are lying in a plane and meeting at a single point, then we will tell that this is the coplanar concurrent force. When all the forces are in a single plane and line of action of all the forces is not passing through a single point. Means suppose that 5 forces is there. 4 forces are passing through a single point, and 5th force is not passing through that point. That is passing through the other different point. Then we will tell that the system will be said as the coplanar, because all the forces are in the plane, but they are not concurrent. So we tell coplanar non-concurrent force system is there. So when this situation will be there, when the coplanar non-concurrent, then what will happen? Then moment will be produced. Okay, so up to here, parallelogram law of forces, component, Polygon's law of forces, Lami's theorem, whatever I have discussed, that is the coplanar concurrent forces there. So when the coplanar non-concurrent forces is there, then resultant will be there, and also that these are also in the equilibrium conditions. Okay, so here the first you understood that what is a moment. So moment of a force about a point is the measure of the rotational effect of the force. You are applying the force, and by that force some rotational motions will be created. You are seeing the door of your house. That is one point, it is hinge, it is rotating, that you have made in such arrangement that it is rotating. But for every action, closing and opening, you are applying the force on the corner of the door. So when you are applying the force, your action is just you are pushing a force you are applying, and it is rotating. So moment of a force about a point will become the hinge, that when hinge, that where you have put the axis of that one where it is rotating. So about that point is the measure of the rotational effect, because at that point it is rotating. So this rotational effect is called the moment. So moment of a force, because you are applying a force and a rotational effect is created, so moment will be created. Moment has been created. So moment of a force about a point is defined as the product of the magnitude of that force and the perpendicular distance of the point from the line of action of the force. Perpendicular distance of the point from the line of action of the force. The point about which the moment is considered is called the moment center, and the perpendicular distance of the point from the line of action of the force is called the moment arm. So that's why you are seeing, if you are applying and by point 1x, assume that it is rotating. So by point 1x, this effect has been created, rotational effect has been created. So if you are applying, and that is the perpendicular distance, so moment will become fd1. Same way, other different point you want to create the rotational effect 2x, because at that point 1x you have applied F1, and by point 1x it is rotating, but you have to keep the system is in equilibrium, because you are studying the equilibrium of systems of coplanar non-concurrent force. So creating that effect has been created a rotational effect, and you have to oppose it, means same amount of rotational effect you have to create it in the other directions. Then what you will do, whatever the you have taken the points of rotation 1x, you take it into the other side of the force. So you are seeing here d1 is 1 point is below the right hand side of the f's, so you take the opposite side of this, so 2x will be there. And if you can increase the distance, or if you can take the point 2x somewhere else, then d2 will vary. When d2 will vary, then applications of force will become the different. Magnitude will become different. If same force you are applying and you want to create the same effect, then d2 will also remain the same, and this way you can change this way. So 2x will become, from 2x it will be, that force will created in the opposite directions of that. Okay, same force, when you have changed the point from which it will be rotated, that location point you have changed, the moment direction will become different. So you are seeing that if you are applying this direction, so FD will create in the clockwise directions, and this FD2 will create into the about 0.2x in the anti-clockwise directions. So when this both will be equal, then d1 will also should be equal. And suppose that you are applying these two forces and you want that is some other point, by that point the moment effect will become the 0. Then you are applying F here. If suppose that at point 1x you are applying F1, other point F2x you are applying F2, and by some other point you want that these two effects which has been created by F1 and F2 should will become the 0. Means 0 means whatever the effect of this turn in the opposite direction, you will create the moment, so the system will be equilibrium. So that will be discussed by the variance theorem. So if two moment is there, and by the third line of action of force you apply so that the moment will become the 0, then you have to increase the, and whatever the resultant will be there, because you have applied two forces, and these forces have created the moment. So if a point lies on the line of action of the force, the moment of force about that point is 0. You have seen that M1 is in the clockwise direction, M2 is in the anti-clockwise directions. So to find the directions of the moment, imagine that line of action of the force is connected to the point. Hello.
Sir. You are audible, sir.
Yes, sir, you are audible.
No problem is there, na? Okay, you are getting or not?
No, sir. Yes, sir.
Yes, sir.
Yes, audible. You are audible. Yes, sir. Yes, sir.
Okay. 12%. So this way you can so to find the direction of the moment, imagine that the line of action of the force is connected to the point by a rigid rod at the moment center, and it is free to move around the point by the force. So the direction of the rotations of the rod indicates the direction of the moment by the force. So this has been given by the French mathematician that is called the Barigans. His name is Barigans. So he has given the principles that is called the principles of moments. So what he has given? The algebraic sum of moments of a system of the algebraic sum of moments. Before that one we have studied algebraic sum of the forces. Here what we'll discuss? Algebraic sum of moments of a systems of coplanar forces about a moment center, means about a point, is equal to the moment of the resultant force about the same moment center. Have you understood or not? The algebraic sum of moments of a system of coplanar forces about a moment center is equal to the moment of the resultant force about the same points. Means whatever the point you have taken 1A or 2A, and third point is there x3. By x3 you have taken the moment. Okay. So you calculate the moment about x3 of force F. Moment about x3 of force F. Moment about the point 2x of force F. And you want to check the moment about any point 3, from that one you take the moment. So all by that point you take the moment about point x3. Imagine that x3 is not lying in this one line, and imagine that the force F is something others, F1, F2. At point 1x, that d1 distance, F1 force is there. At point 2x, d2 distance, d2 arm length, force F2. And at point x3, which is the different point in this plane, then you calculate the moment. So moment of F1 about x3, you will get some value F into d1. Moment of F2 about x3 is equal to the resultant of these two forces, whatever the resultant F1 and F2. This is equal to the resultant, and that is the perpendicular distance and passing through the point x3. Okay? This way you understood this way. You want to calculate the moment about here, this point. F1 is here, F2 is here. So F1 is acting, this point is here. So draw the perpendicular distance. So this way, by this point you will get the rotational effect. So this F1 and perpendicular distance from this point. Okay. Imagine this is the D1. So moment will become F1 into D1. This F2 application of force, and draw the perpendicular distance from here, this point, because by this point you have to create the rotational effect. So this will become the D2. So distance D2 will become the perpendicular distance from the line of action of the force that you have to keep in your mind. Means if this force you will extend and point is here, so draw the perpendicular from here in such a way that it will pass through the point of rotations. So F1 into D1 plus F2 into D2 is equal to R is passing here. So from R you draw also perpendicular distance and it will pass through the this one about the point by which the rotational effects you have to create. So this F1 D1 plus F2 D2 is equal to R into D3. This is the variance theorem. So algebraic sum of moments of a system of coplanar forces about a moment center, x3 is a moment center. Take some other point that C is passing here. Imagine that C is somewhere, F point is there or T point is there. By that T point you want to calculate the rotational effect. So by T point, F1 into perpendicular distance which is passing through the point D, and that perpendicular distance will be perpendicular to the force of F1 and also should pass through the point of rotations. In the same way, F2 will pass from that one point and the perpendicular distance from the F2. In the same way, perpendicular distance from the R. So F1D plus F2D2 is equal to R into D3. So this will become the algebraic sum of moments of a system of coplanar forces about a moment center. Moment center is point T or some other. You have taken in the plane some other point. It's equal to the moment of the resultant force. Resultant force is here R. About the same moment center, that point T. Is it clear to you? Is it clear to you?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
So this is called the variance theorem. So you can apply the variance theorem for calculations of that one, and you have to calculate the moment of that one. Okay. So suppose that where you have to apply these. So suppose that a rod is suspended, a rod is supported from the wall and floor of your building, and you have applied somewhere force. That rod is resting, so some force is acting on that one, on the ground and on the vertical wall of that one, both way. And if you are from the ground you are pushing it, so on the vertical wall it is increasing, vertical distance is increasing. So this will become a right angle triangle. Length of the rod will become the hypotenuse of the right angle triangle. And you want to calculate the moment about the horizontal plane and vertical plane where it is meeting by that point. You want to calculate the moment. Then whatever the force is, their weight is acting, from that one weight you draw the perpendicular distance, and that perpendicular distance and that much weight and horizontal force, that perpendicular distance you calculate, and you will see that what is the moment is there. In the same way, y-intercept you will calculate, and you will calculate the moment about that one point. X-intercept, y-intercept, this way you can calculate. So if this is called the moment, if two parallel equal forces in magnitude, two parallel forces equal in magnitude, here you have seen that F1 and F2, these are not the parallel, they are coplanar, but concurrent is there. So when the coplanar and parallel forces is there. In a plane, two parallel forces is there, equal in magnitude, but opposite in direction, and separated by a definite distance, then moment will be created, and that is called the couple. Two parallel forces equal in magnitude and opposite in direction and separated by a definite distance are said to form a couple. The sum of the two forces forming a couple is zero, since they are equal and opposite, which means the translatory effect of the couple is zero. So what you will get? You will get the rotational effect. Opening of the taps of the this one, water pump, or here opening the nut. Okay, so you are applying the two opposite forces, but it is rotating. When some unbalanced forces will there, then it will start opening in that one direction. By a single force you cannot open. Here you have to apply. So two opposite forces will be there, then a couple will be generated, and when the increased value you will there increase, then it will open. Okay, so see here that this point 1, by this point you want to, this is the axis of rotation. So you have seen when you by some way your tap has that water is not stopping, it gets leaking. You will see when it will open, plumber will open, then you will see that they are opening some upper portions, and you will see that here the axis is there, and in that one axis you have put a support, a screw thread. So when you are rotating, it is going down and blocking the pipeline supplying of the water from that one point, so it gets stops. So in the same way you are seeing that you are applying the force here, but effect is coming at this point A, 1, and it is opening. When that valve gives the space, then water is flowing. When they blocks, the water is not coming out. So this moment, this is the principle, sir, you have applied that one. Every valves opening, flow meter, everywhere that this phenomena is happening. And opening of this way and this closing, you can do by your hand, by force, or by flow of any gas, or by electrical signals, or by the mechanical systems, or by the software systems. So this will become the automated systems. So if some race will give the signal, it will open and it starts giving the opening of that one, and then water flows. When there is no signal, it blocks the part. So principles is there and application is different way that we are doing. See here the different point is there, F1 is here, F2 is here, and by 2 point you want to get the effect. So now consider the moment of the force about the point which is outside the two forces as shown is there. So moment M2 will be calculated. M2 is equal to F D3 minus F D4. Same forces is there. Parallel forces is there. So F D3 minus D4, and that you have given D. So this is FT. So this is called the variance theorem. So you have seen that resolution of the forces and resolution of the couples, that how you can calculate that the point. You can, by some way you have calculated the resultant, and some way you have calculated the rotational effects. So resultant of the non-concurrent force system. So resultant of the force system is one which will have the same rotational and translatory effect as given in the system of the forces. So if this way you can calculate. So we can solve some problem. Okay. Okay, in the next class we will solve some problem because here 420 is there. So in 10 minutes you will not solve the problem. Okay. So wait for some time. I will take your attendance. Praveen. Praveen.
Yes, sir. Yes, sir.
Wait for some time. I am taking your attendance,
Okay,
and
sir.
I will match in the next class.
जी sir.
Wait, somewhere it is coming. Okay, thank you. We'll meet on Monday, and Monday is the tutorial class. So in the tutorial, we will solve some problem. I will give you some problem. You have to solve that one problem, Abhishek. So related to this one, resolution of force, finding out the resultant, Lamis theorem. Okay. So you refresh it. We will discuss on Monday. Okay.
Okay, sir.
Okay, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Thank you,
Thank you.
sir.
Thank you, sir. Bye, sir.
Thank you, sir.
Bye.
Bye-bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
भाई मार रहा है
Thank you, sir.
थैंक यू सर
चले गए भाई,
चले गए
ये 50 मिनट
चलो, आज तो
समझ आ रहा था कुछ सही।
बोलिए सत्यनारायण
ये 50 मिनट झेल ही नहीं जा रहे थे।
ज्ञान भैया क्या हाल?
अब नाम लेगा।
कि सबसे बदतमीज तो हमें केमिस्ट्री वाला लगा, कह रहा नेक्स्ट वीक से देखेंगे। बोल रहा नेक्स्ट वीक से देखेंगे। ये अलग ही है।
उसकी प्रोनाउंसिएशन ही खतरनाक थी।
विजिबल
प्रवीण आज पूरा बुक नहीं लगा लेगा तू आज नहीं? पूरा बुक चाट देगा वो।
आज प्रवीण को पकड़ा था
भाई यार, सर दर्द करने लगा सही में।
आ जाऊंगा।
उससे क्वेश्चन नहीं पूछा, बच गए।
ये बन जा सर, अच्छा रहेगा।
भाई बीजीएमआई वाला कौन था बंदा? बीजीएमआई वाला
हाँ, उसका बताओ। सही था भाई।
चार घर लूट लो,
घर लूट लो, घर में एक घर ले लो, एक घर ले लो।
कौन से छेद से मार रहा है?